My name is Sebastian. I'm a PhD student at the University of Tübingen in Germany, and I'm going to present our recent work, Post-Hoc explanations fail to achieve their purpose in adversarial contexts. This is joint work with Michele Finck, Raidl, and Ulrike von Luxburg. Let me quickly give a high-level overview of this project. On one hand, this is a project about the regulation of machine learning systems, and in particular about the Artificial Intelligence Act, which is currently being negotiated in the European Union. On the other hand, this is a project about a particular class of methods, namely local post-hoc explanation algorithms. The question that we are going to ask is, what can we expect from these algorithmic explanation methods, and under what circumstances should they be part of the regulation of machine learning systems? As we are going to argue, we should not expect too much from these methods. In particular, if the decision-making context is adversarial, they can quickly become useless or even harmful. Let me now introduce the distinction between cooperative and adversarial decision-making contexts. This distinction is going to be very important for our argument. In a cooperative decision-making context, all parties share the same goal. Stylized examples of this are scientific discovery and model debugging. But also medical applications of machine learning can, up to a point, be seen as cooperative decision-making problems. In a medical imaging task, for example, one might approximately assume that the developer of the machine learning system, the medical doctor who employs it, and the patient all share the same goal: to make the best diagnosis. In an adversarial decision-making problem, in contrast, the incentives of the different actors are not aligned. A well-known example of an adversarial decision-making problem is a loan application. In a loan application, the applicant and the bank have different interests and incentives. The applicant, for obvious reasons, wants to get a loan with a small interest rate. The bank, in contrast, does not care about the applicant directly and simply wants to earn money. Importantly, while this is a project about algorithmic decision-making systems, whether a decision-making context is cooperative or adversarial has nothing to do with whether we use an algorithmic decision aid or not. This simply depends on the social context in which the decision is made and the incentives of the different actors. Let us now illustrate the role of algorithmic explanations in an adversarial decision-making context. Here we use again the example of a loan application. In this example, an individuum applies for a loan. Suppose that the loan application is rejected on the basis of a machine learning algorithm developed by the bank. Now, in addition to the information that the loan application is rejected, the bank also provides an explanation as for why this is the case. In order to do this, the bank uses one of a large class of post-hoc explanation algorithms that have been recently proposed in the literature. These algorithms look at the decision function employed by the bank and then try to come up with an explanation for why a particular decision was made. Importantly, these algorithms work in a post-hoc manner, which means that they are not part of or integrated into the decision-making process itself, but try to explain the decision after the fact. As illustrated on this slide, there are different forms that such an algorithmic explanation might take. What are the motivations behind the idea that the bank should provide an explanation? One idea is that the explanation might help individuals to contest machine decisions. Others have suggested that they might allow individuals to alter their behavior and obtain different outcomes in the future. It has also been argued that explanations might enhance trust into automated decision-making or serve consumer protection and education purposes. The main message of our paper is that in adversarial context, post-hoc explanation methods fail to fulfill all of these objectives. Before we go into the details of why this is the case, let us situate our research question in the context of European Union law. In the European Union, there are two main legislations that are relevant for automated decision-making systems. One is the GDPR that many of you have probably already heard of. Another is the so-called Artificial Intelligence Act. The Artificial Intelligence Act is a piece of recently proposed legislation that would be the first to specifically target artificial intelligence systems in the EU. I am now going to give a very quick overview as to whether explanations are a requirement according to European Union law. For the details of this, please have a look at our paper. As far as the GDPR is concerned, there has been an academic debate as to whether recital 71 amounts to a right to an explanation. Whether this is actually the case will probably have to be settled by the courts. In any event, this would only apply in specific circumstances. In general, the GDPR does not create a right to an explanation. The current draft of the Artificial Intelligence Act specifies general transparency and interpretability requirements. In particular, the draft specifies that so-called high-risk AI systems must be sufficiently transparent to enable the interpretation of their output. However, it seems unclear at present what exactly this requires from a technical perspective. Thus, while the transparency requirements in the Artificial Intelligence Act might be interpreted as relating to algorithmic explanations, these are not explicitly required. However, they might be seen as a subcomponent of transparency. Let us now turn to the discussion of the problems with post-hoc explanation algorithms in adversarial contexts. The big problem is that there is no well-defined notion of ground truth explanation. In a complicated black box machine learning system, the different input variables can contribute to the final prediction in many different ways. Thus, while it might be possible to explain certain aspects of a given decision function, holistic ground truth explanations do in general not exist. Moreover, explanation algorithms only have access to a certain description of the world, given by a decision function and a dataset. Thus, even if a good explanation for a particular machine prediction exists in the real world, it might still be impossible for an explanation algorithm to provide it. From a computer science perspective, the problem with algorithmic explanations is that they are highly underdetermined. This means that for every given prediction, there are many different equally plausible explanations and explanation algorithms. On the next slides, we illustrate the problems with post-hoc explanation algorithms with a number of different examples. In this discussion, it is always important to keep in mind that we are concerned with an adversarial context, where the explanations are provided by an adversary who will try to provide explanations that align with his incentives. One problem with algorithmic explanations is that there are many different, equally plausible explanation algorithms. In practice, these algorithms lead to different explanations even for quite simple problems. In the figure on this slide, we depict the explanations of 4 different algorithms that all attempt to explain which input variables are most relevant for the prediction. We see that the explanations differ. For example, the second algorithm determines that feature number 9 is most relevant for the prediction, whereas the first algorithm determines that this feature is not relevant at all. In a cooperative scenario, the different explanations might still be useful. Perhaps we will find an explanation algorithm that delivers interesting insights. In an adversarial scenario, in contrast, the explanations will not be useful at all. Out of all the different possibilities, the adversary will simply pick an explanation algorithm that makes the machine predictions incontestable. Another problem with algorithmic explanations is that they depend on the exact shape of the high-dimensional decision boundary. Thus, even if we fix a particular explanation algorithm, there is still ample room for the adversary to influence the resulting explanations by modifying seemingly unimportant details of the machine learning system. This can be seen again in the figure on this slide, where the same explanation algorithm produces different explanations for only slightly different decision functions. The third problem with algorithmic explanations that we want to highlight is that they often depend on the composition of the dataset. This is again problematic in the adversarial scenario, where the dataset is usually assembled by the adversary. In the figure on this slide, we give a simple example where the choice of the dataset determines whether one or another variable was important for the prediction. In summary, while algorithmic explanations might seem objective, they do in fact depend on many human choices, such as the composition of the dataset, the trained machine learning algorithm, and the choice of a particular explanation algorithm. For these reasons, we argue that it does not make sense to regulate machine learning systems implicitly via their explanations. Instead, we should test and regulate decision functions directly. Moreover, in critical applications where manipulation concerns are high, the only solution might be to demand the usage of an a priori interpretable classifier. This idea is, however, not part of the current draft of the Artificial Intelligence Act. In conclusion, we find that post-hoc explanation algorithms fail to fulfill their purpose in adversarial contexts. However, we also want to highlight that it is not directly clear how the different transparency and interpretability requirements inherent in the law can be fulfilled from a technical perspective. While this is clearly an important question, we think that it requires much more research. As a final caveat, note that even in adversarial contexts, the adversary might choose to deliver useful explanations. The important point is that these explanations will serve the individuals only insofar as they also serve the adversary. Most importantly, they will never allow individuals to challenge the adversary in ways in which he does not want to be challenged. Thanks a lot for your attention. For more details, please have a look at the full version of our paper.